Today we are going to discuss about pooled regression. How to pool two independent cross-section samples and then how to estimate the time effect by allowing interaction time dummy. And we will do that with the using the data of 55th round of employment unemployment survey of NSSO and 68th round of the employment unemployment survey of NSSO. So, when we take the data, when we collect the data of the same variable, but for different time periods and for different individual units, the individual units are not same. So, when such a data is collected, then in order to do the regression, we pool these samples of different time periods, and then we just do the OLS. This kind of regression is called pooled regression. That means we are pooling the cross-sectional data from different time periods about the same variables, but the observational units are different. This should be kept in mind, that observational units are different, and that is the difference between the panel data and the pooled data. Because in case of panel data also we take the information about the same variables, but we collect the data from the same observational units repeatedly at different time periods. And in such a case, in case of panel data, we can find out the fixed effects, that is the effects of unobserved heterogeneity across the individuals. We can do that, but in case of pooled samples, since the observational units are different, so we cannot find out the fixed effects, and we just do the OLS regression, but we can find out the effect of change of time by using the time dummy variable and interaction time dummy variable, interaction dummies of time with other variables. So, in this way we can find out the time effects to some extent, but not as good as the panel data. But when the when there is no panel data available, like in India, you can find panel data very hardly. Apart from the macroeconomic variables, you cannot actually find out the panel data. So, in order to do the regression and find out the time effects, there is no other way than to use the pooled regression. So, pooled regression is very much important if you are interested to do the empirical research from Indian data. So, let us discuss it in detail. Suppose the linear regression model, the equation is y equal to b0 plus beta 0 plus beta 1 x1 plus beta 2 x2 plus u, where u follows the normal distribution and it has mean 0 and standard deviation and variance sigma square. So, in such a case, we are actually having two groups of data, group 1 and group 2, with the same variables. So, we can separately estimate these two groups by OLS regression using the standard regression command, that is regress y x1 x2 if group equal to 1, and then regress y x1 x2 if group equal to 2, or from the same data we can pool it and estimate a single model. Then we have to generate G2 equal to within bracket group equal to 2, and G1 is obviously the same the original variables. So, G2 is for group 2, and then generate G2 x1, that is for x1. For the first time period it will be only x1, and for the second time period it will be G2 x1. So, generate G2 x1 equal to G2 star x1. Then also for x2, for the first period it will be only x2, and for the second period it will be G2 x2, that is G2 generate G2 x2 equal to G2 star x2. So, then we regress y on x1 x2 and G2 and G2 x1 and G2 x2. So, the difference between two approach is that in case of separate regressions, the standard deviation and the variances of the residuals are different, but when we are pooling them, we are assuming that the variance is the same. So, there is one restriction in the pooled regression model. As a result, since the variance is assumed to be the same, which is not actually, so we have to correct the standard errors when we are pooling the for some times, because if the standard errors if the standard variances are same, then there is no problem. Sigma 1 square and sigma 2 square, if sigma 1 square equal to sigma 2 square, then we can safely assume that they are same as sigma square. But if it is not, then we have to do the robust command. We have to use the robust command to correct the standard errors. So, for group 1, the equation is y equal to beta 0 1 plus beta 1 1 x1 plus beta 2 1 x2 plus u1, and then for group 2 is beta y equal to beta 0 2 plus beta 1 2 x1 plus beta 2 2 x2 plus u2. Then after pooling them, what will be the equation? Y equal to beta 0 1 plus beta 1 1 x1 plus beta 2 1 x2, that is the equation for the period 1, and then plus within bracket beta 0 2 minus beta 0 1 into G2, that is the change in the in this way we are measuring the change in the intercept. Then within bracket beta 1 2 minus beta 1 1 into G2 x1, that is we are measuring the change in the coefficient of x1, plus within bracket beta 2 2 minus beta 2 1 into G2 x2. Once again we are measuring the change in the coefficient of x2 plus u. So, we perform this estimate with the real data, and we in this way we observe that the same values of the coefficients we will get the same values of the coefficients. There is no difference between these two regressions, that is separate regression and the pooled regression, but we will have different standard errors. So, standard errors are different, and therefore different state statistics, different confidence intervals. So, if you know that you have same variance in the two groups, then standard error is perfectly alright in case of pooled regression. But if they are different, then standard errors obtained from the pooled regression will be wrong. So, therefore, we have to correct the standard errors after performing this pooled regression. So, using the robust command. But first, after performing the pooled regression, we will check whether there is any heteroscedasticity, and if we find that there is heteroscedasticity, then we will correct the standard error by using the robust command. So, how to estimate the time effect? Now, in the earlier whatever I have discussed so far, I have not introduced any kind of timing variable or anything like that. So, in order to measure the changes in the effects of the explanatory variables, we have to use the time variable. So, first of all, we should append the two data for pooling, then we will use the use all the other observations. So, let us start from our data sets, that is we have two data sets, one from 55th round and another from 68th round, and we just append them in order to get the pooled data set. So, before appending, some important point should be kept in mind, that the data which would be pooled should have the same identical variables. If you have different variables, then you cannot append them. So, you should have the same identical variables. So, before giving name of your variables for the two data sets, you should keep in mind that there should be no change in the names. Names should be identical, and after that we can append the data sets. And how to append the data sets? Let us go to the data set. Now, first of all, start with the log file. So, just begin with the log file, give the name pooled regression, save. Now, open the how to get the names, that is also an important point. So first of all, open the 68th round, okay, then clear it. We just did it in order to get this name here, so that we can copy and paste. So clear. Then again you open the 55th round data set. Here there is one year variable, and year is for 1999. You can check it. From here you can check it, the year is 1999. Now the command is simple, append space using, now copy and paste this 68th, copy and then paste, and then just click enter. Now your data set is appended, that is pulled. You can check it from here. The year variable has 2 years now, 1991, 1999 and 2011. 2011 for 68th round, 1999 for 55th round. So we have pooled our data set for a single data set. Now give a name to this. Save as '55, '68 pooled, sorry, '55, '68 pooled data. So the data set is saved, it is the pooled data set. Now we should go to our discussion back. So now, suppose we are trying to find out the explanatory variables for variations in the wage total. So we are doing the same exercise which we have done in case of simple regression. So for that we have to generate our variables, so that is age square, then we have to find out the missing variables of wage total, and then drop all the 0 wage totals, and then we should get the log version of the wage total, that is ln wage total. So we first begin with doing all these things. Go to the data set. Now generate age square equal to age to the power 2. Okay. Now wage total. Replace wage total equal to 0 if wage total equal to dot. Now drop if wage total equal to 0. So we have dropped all of them and we get only positive wages. Only here you can see we get only positive wages. So in this way we prepare our data set, and then one task is still we have to do, that is generate ln wage total equal to ln within bracket wage total. So we have created the log value of wage total. Now we have to regress it. How to regress it? We get different variables which are qualitative, and instead of creating dummy variables by name, we are just taking the command I dot, so that all the dummies, all the codes are converted into dummy variables, and they are automatically included in our regression, leaving one dummy variable from each of the sets, just to avoid the dummy variable trap, as you always know this, and the software automatically does it, you do not have to do anything. So our just, and then again we are using the time dummy variable also in order to find out the change in the intercept. What is the intercept? Intercept is those variations which could not be explained by any explanatory variables, those variations in the wedge. So over the years, whether there has been any change in that unknown portion of that variation, we have included the year dummy variable, and since there are 2 years 1999 and 2011, we are using I dot year. So I dot sex, I dot gen edu, I dot take edu, I dot HHD religion, I dot HHD group, and I dot marital status, and then lastly I dot year. So this is our regression command. Since it is written here, I am copying and pasting there, but you can type it there, there is no problem. You can directly type it there. So we have taken this, all of them, and so as you see that all the dummy variables are automatically created, and according to code they are written. Now if you are doing any research paper or anything, then you should just, where you are displaying your result, you should just change the name. Now here 2.sex is written, here you should write the name female, because you know that the code 2 is for females. Similarly, you can change the names of all these codes. So which codes are for which group, you can find them from the layout of the 68th and 55th round data set. It is given by NSSO, so you can put the name, change the names of the codes, and you can use them in your work. So one task is remaining, that we have to check whether now suppose we see that ER variable has positive coefficient, that means the variations in the wage has increased, that means over the years. So wage has increased over the years. Unknown portion for which wage has increased, the unknown effects have increased. If unknown effects have increased, wage has also increased. So over the years, unknown effects for positively affecting the wage rate has increased over the years. This means this. So coefficient for the earlier equation, if we would do the separate regressions for the separate data sets, then our coefficient would be 5.210916. This one would be for 1999, and for 2011 it would be 5.210916 plus 0.7305211. If you can calculate it and then to check it whether the coefficient is same, you can easily do the separate regressions and check them, they will be same, there is no variation. So this is the process. Now we have to check whether there is any heteroscedasticity, because we have restricted the assumption that standard error, standard deviation, variance of the residual term is same, but it may be true that they are actually different for these two time periods. So to check them, we have to check that we have to use the heteroscedasticity checking command, that is stat het test, and we see that it is 90%, it has 90% significance level, so it's not too insignificant. So therefore it's better if we use the robust command in this case, although it is not highly significant but quite significant. So therefore better we use the robust command. So we are using the same thing, just give the comma and put the command robust. Okay, so just give the comma and put the command robust. So now wherever we have whatever the results, these results are correct because our standard error is robust. we have checked our standard errors, checked the errors. So, this is our result, and over the time period here again you can see that the result is same. And females, if anybody is female, then he is getting lesser wage rate than the others. Here the female dummy for 2011, no, for all the years, female dummy, it is the female dummy. So, female dummy has minus 0.3512224. So, therefore, it has a negative and highly significant coefficient. So, therefore, females are significantly getting lower wages than males as per our results are concerned. So, in this way you do it. Now, you can obviously what I was saying earlier, that you can do the regression separately, and then you do not have to do the robust command, use the robust command, because here the standard errors are here the variances are different, and you have taken that assumptions. So, therefore, there is no necessity to use the robust command, and you can just check whether the what I was saying, that regarding the values of the coefficients. So, you can do them separately. Let us do them separately and check whether we have the results as I was saying earlier. So, in this case your constant term is this, and in earlier case you got the constant term this. In this case we get constant term this, and if we use the robust command, then also we have this. Okay. Now, do the second one for 2011. Now, if you add up, in the earlier case, if you add up this one with this one, then you will get this one, and you can prove that these are giving the same results. Here also you can check so this is significant, therefore we have to use the robust command. After using the robust command, this is the coefficient. You can go through the same calculation, you will see that you will get the same results as in the which you can calculate from the earlier pooled regression. Both these methods will give you the same kind of results. So, there is no problem. So, now how to use the time dummy, interaction time dummy, that is, suppose we are interested to know, here we can find out only, let us go to the pooled regression result. Now, here suppose we are trying to know the changes in these variables: female, general education, technical education, household religion, household group, marital status, all of them. how they change, how their effects change, effects on log wage rate change with the time. And for that purpose, you have to use the interaction time dummy variables. Now, I will show you certain dummy variables, how to use them. For this purpose, first of all, we have to create. We cannot use now the I dot command, because that will give us a big results, because each of the variables has several codes, so that will be very complicated, give us very complicated results. So first of all, we have to create the dummy variables in the general process, which I have already taught you. So first of all, we have to generate them. So let us begin with generating the year dummy. So tabulate year, generate year. Okay. We cannot use I dot year. We have to create them manually. So this called year 1999. This is called year 2011. We have to change the names in this way. Okay. So rename year 1 YR underscore 1999. Rename year 2 YR underscore 2011. We have given them the names. So in this way, we have created two time dummy variables. Now let us create the gender dummy variable. So tabulate sex, generate gender. Okay. So tabulate sex, here given sex variable, generate gender. You know it has got two codes, so two dummy variables will be created. Oh, sorry, it has got the capital. So it will create two gender dummy variable. Gender 1 is male and gender 2 is female. So rename gender 1 male, rename gender 2 female. Okay. So we have created sex dummies. Generate. Now let us create some caste dummies. Okay. So caste 1, caste 2 and caste 3. There are three codes. Caste 1 means SC, caste 2 S. This is wrong. This should be ST. Sorry. This should be ST, this should be SC, and this is so. And then we will drop the caste 4. So tabulate HHDGR, generate caste. HHDGR means HHD group. Here it is given, this one. So tabulate HHDGR, generate caste. So this has created four dummy variables. Now rename caste 1 ST, rename caste 2 SC, rename caste 3 OBC, and drop caste, sorry, OBC. Rename OBC. Okay, now drop cast 4. So 3 cast dummy variables have been created, ST, SC and OBC. Now let us begin with them. Now if you wish to do, you can we should do these same things for general education and for technical education. Then in the same process you have to create some dummy variables by name at first, and then you can interact them with the time dummy. So let us interact the female dummy with time dummy. Now we take the year 2011, because female, for simple female means the overall female, and simple the first 1999, and then the 2011 it actually indicates the change in the female dummy over the time period. So we are just creating the interaction dummy for 2011. So xi space I dot female star year 2011. Now as you already know, the first one is the original female dummy, so we drop it because we already have it. Now rename the second one as let us check whether I have given the same name in the original PPT slide. Yes, FEM 2011. Oh, sorry. Rename this as FEM 2011. Now this has been created, the gender dummy at 2011. Now we can already we can also use the SC dummy, ST dummy and OBC dummy in the same process, interaction dummy variables. Okay, so xi space I dot ST star year 2011. So first dummy is the ST dummy, drop it. Rename the second dummy as ST underscore 2011. Once again, xi space I dot SC star year 2011. Here also the first one is SC dummy, so drop it because we already have it, and then rename the second one as SC 2011. Now xi space I dot OBC star year 2011. Sorry, year. You should be very careful while using the names, because if you by some mistake, if the name is mistyped, then wrongly typed, then see this kind of red alert will come. So just be careful while typing. So drop the first one and rename the second one as OBC 2011. So we have created the interaction, all the interaction dummy variables we needed. Now you can go on in the similar process to do others also. So in this way we just calculated, and now we use the regression command and where you include age square, female. Then we, since we have not created any dummy variables separately, so we have incorporated them in the earlier fashion, that is I dot gen edu, I dot tech edu, I dot hhd religion. Then we use st, sc, then I dot marital status, then year dummy variable, then female 2011, then ST 2011, SC 2011, and we can add with them, since I have also calculated OBC, so OBC 2011. Now give the oh sorry, we just wrongly typed the name. Now it will take. Okay, so as you can see that how the changes over the years have been, what are the changes, these have been displayed. So females were getting lower wages than male already, and in 2000 they are getting much lower wages, far more. STs were getting did we use them, ST and SC, marital status, let us see. What? Why are we not getting them? Yes. Now you can see STs were getting higher wages than others, but in 2011 the amount of higher wages declined. SCs were getting lower wages than others, but their gap has decreased over the years. Now OBCs were getting, we have not used the OBC original, so we can also use the OBC here. This is a step-by-step process, trial and error method. You can do the same exercise repeatedly to check a number of variables. So OBCs are getting, we are getting lower wages, here you can see, than others, and now in 2011 their wage gap declined. So in this way we can find out all, we can use the time dummy variables, interaction time dummy variables with the other variables, and it seems the same thing can be done for general education, different categories. You need not have to take all the categories, you can choose, you can just first create the dummy variables separately, and then you can choose them whichever you are in which you are interested. So you can pick them selectively from the technical education, from religion, from marital status, whatever. So you can do the same exercise, and that will be your home task, that will be your home assignment. Do these things similarly and complete the regression in the same. Here we have only used the female interaction with time, ST, SC, OBC interaction with time, and you do the others. Now let us check whether this regression has heteroscedasticity. So you start het test, and you can see that it is insignificant, so there is no heteroscedasticity in our model. So this is the correct model. So in this way you can pool your regression, pool the cross sectional from different time periods, not only from 2 time periods. You can actually you can append the data set from 3, 4, 5, as many as you can. you can pull them together and you can do the same exercise, and in such a case you have to use the separate more than one time dummy variables and you can check them. And but before appending, you should keep it in mind that your variables should have identical names and there should be same number of variables for all the data sets, and after that only you can append your data sets, and you can after that you can save your new data set, appended data set as the pool data set, and then you can perform the regression, and you can create as many as dummy variables, as many as interaction time dummy variables. Interaction, suppose you can calculate female interacted with SC and interacted with ER. So, female SC ER, females who were from scheduled caste, how their effect changed over the time period, how they changed in, how that effect, SC females effect changed over the years. So, in this way you can create as many as interaction dummy variables. It depends upon the upon your choice and your understanding about the research problem, and then you can explore it deeper and deeper using these weapons. And the interaction dummy variable is a very good weapon to explore, to penetrate into the problems and to find out the smaller and smaller unit for smaller and smaller units, all the effects. So, you can do this in this way. So, do the exercise at your home and then tell me if you find any problem. You can always contact with me, and your PPT slide and the log file and the data sets will be given to you, will be mailed to you, and do the exercise as I have instructed. And you need not save this one, because if you save this, then these dummy variables will be saved, then you cannot repeat the exercise once again. So, you should not incorporate these dummy variables. You can do them and then you can just without saving, you can come out, so that your only your pool data set, original pool data sets will remain there, and you can do the exercise as many as times as you wish. So, thank you.